Okay, so I'm going to look at this question here. It says the following table shows the average body weight X and average weight of brain Y of 7 species of mammal, both measured in kilograms, kg. Right, then we've got our data here. It says find the range of the body weights for these 7 species of mammal. So range of the average body weight. So average body weight is this column here. And then the range means the largest value take away the smallest value. So the smallest value looks to be cat, which is 3. Largest value is giraffe, which is 529. So to find the range, we just need to do 529 take away 3, which is 526 kilograms. Then it says, from the data of these 7 species, calculate R, the product moment correlation coefficient. So we can use the GDC for that. So to enter the data in, what I need to do is press Stat, and then go to Edit, and I see my lists here. I have a bunch of stuff in these lists. I'm just going to clear all that out before I start by going up to the top of each column, pressing clear. So move up to L2, press clear, then press enter. Move across, up, clear, enter. That gets rid of all my data. Then I need to enter the data for the animals. So first is cat, which is 3, then cow, which is 465, and so on. 187, 529, 28, 156. Then I need to go across to L2 and enter the data for the brain weights. So 0.026, 0.423, 0.419, 0.680, 0.115, 0.157, and finally 0.175. Okay, once I've got the data entered in, then what I'm asked for first is to calculate Pearson's product moment correlation. So what I do is I press Stat. Before I do that, I should check that I have the Stat Diagnostic turned on. So if I just press Mode, I can see here that Stat Diagnostic is off. So what I need to do is make sure that that is on first. So let's just move across and press that on. Okay, once I have that, I can then go Stat, and then Calc, and then I want linreg number 4. I could use number 8 as well if I wanted, but I'm just going to keep on using number 4 because this is in the form y is equal to mx plus c. So I calculate that. My x list was in L1, my y list was in L2, so that's all good. Just keep pressing enter. And then I need to write these numbers down. So this says A is 9.858, and then this E minus 4 means times 10 to the power of minus 4. So that number is actually 0.000964, because this is times 10 to the minus 4. Then my B is 0.9234. I'm going to need those later, so I'm going to write those down now. Anyway, the Pearson's product moment correlation that I wanted is this R, which is 0.922. So I'm just going to write that down there. Okay, so then a bit later on in the question, it's going to ask me for y is equal to mx plus c. So I'm just going to write those down now, and then when I get to that part of the question, I'll be able to copy those in, because I can see that it's going to ask me for that later on. Okay, so I've written those down. Then I'm going to need to go to my graph so I can enter that formula in. Now I think I can enter it in as 9.86 and then E negative 4x plus 0.09234. That should work. Let's just try that out. So what I'm going to do is I'm going to do stat plot and turn that on. so that I can see my points, and then I can check that my regression line does go through my points, and I can be sure I have it right. So then I'm going to do zoom and do zoom stat so that my window is correct. Okay, I can see my points, and then I can also see that my regression line has gone through there, and that's looking quite nice. So that looks like my regression line equation is, I have it correct, I've typed it in correctly, I've got my points there, that's all good. So I can write those things down. So from the GDC, R is 0.922. Then it says describe the correlation between the average body weight and the average weight of the brain. So all we need to do is interpret what this number tells us. So this number here is positive, it's quite close to 1, so we would say that there's a strong positive correlation. Okay, next it says write down the equation of the regression line y on x in the form y equals mx plus c. So we got that from the GDC, I wrote that down on a piece of paper, so I'm going to write that down here. And it's y is equal to 9.86 times 10 to the minus 4 x plus 0.0924. Alright, next it says the average body weight of grey wolves is 36. Use your regression line to estimate the average weight of the brain of grey wolves. So again, we're going to use the GDC for that. Now, what I need to do next is it says the average body weight of wolves is 36 kilograms. Use your regression line to estimate the average weight of the brain of grey wolves. So what I need to do is X is the body weight, which is 36. So what I need to do is I need to find the value of y when x is 36. So the easiest way to do that is, because I already have the equation in my calculator to make this regression line, if I just do second and calc, and then I want the value. I want the value when x is 36. So I just press enter for value, and then I type in 36 because that's the value which I want. And it will tell me there it is, it's drawn the point on the line. So x is 36, y should be 0.128. So that means that the weight of the grey brain wolf brain should be 0.128 kilograms. And we got that the average body weight, or the average weight of the brain, was 0.128 kilograms. Then it says, in fact, the average weight of the brain of the grey wolf is 0.12 kilograms. Find the percentage error in your estimate in part D. So to find percentage error, what we need to do is use a formula. If we don't know what that formula is, we can look at the formula book. So the formula book here says topic number 1, number in algebra, and here 1.6 percentage error is this one. So E is equal to VA minus VE over VE. It tells us that VE is the exact value, VA is the approximate value. So it's the approximate value minus the exact value over the exact value between these bars times 100%. So I'm just going to write that down. So it's VA minus VE over VE and times 100%. So VA was the approximate value. So that was 0.128 minus the exact value, which is 0.12 divided by 0.12, and then times 100%. So using my GDC, I then get that that is 6.52%. Okay, now these vertical bars here, you can treat them sort of like brackets, but what they mean is if the value is negative, then treat it like it's positive. So in this case, we had 0.128 minus 0.12, so we got a positive answer here, which was fine. We then divide it, we get a positive answer. If this value had been small, if it had been less than 0.12, if it had been 0.114 or something like that, then the answer here would have been negative, and these bars mean treat it like it's positive. So you should always get a positive answer here. If the answer comes out negative, just ignore the minus sign and put it as positive. Anyway, percentage error should be 6.52. Then the last part says the average body weight of mice is 0.023 kilograms. State whether it's valid to use the regression line to estimate the average weight of brain of the mice. Give a reason for your answer. Now, when we did the grey wolf, The grey wolf's average body weight was 36. 36 lies within the range of the data. So the range was from 3 up to 529. So 36 was bigger than 3 but less than 529. So it's perfectly valid to use that because we have data within that range, close to that value, and we can use it to estimate it. In the case of the mouse, the body weight for the mouse is 0.023 kilograms. So that is outside of the range of our data. We don't have any data in that region. So we're kind of assuming that the pattern will continue, but we don't know that for sure. So when the data is between, or when we're looking for a value between the data, that's called interpolation, because it's between the points. So the average weight for the grey wolf of 36, it's perfectly reasonable to use the regression line to calculate what you think its weight of brain should be. That's called interpolation because it's between the points. When you have it where it's outside of the data range, but when it's not between the points, that's called extrapolation. Now, extrapolation is quite dangerous. We don't actually know whether that's going to be true or not. Okay, so we'd say it's not valid as it is outside of the range of the data. Okay, that's called extrapolation. I'm just going to show you on the GDC what happens if you try to use that value in this case. I could try to type that in. So I can count and do value again, and then type in x is 0.023. Okay, and that's drawn me a point down there, but that's given me a y value of 0.09. So I can see that that's not really a valid piece of data because the weight of my brain, or the mouse's brain, is saying that it's much more than the weight of the entire mouse. So that wouldn't make any sense, right? Also, it's outside of the range of the data, which is why it's not reliable to use it in any case.